Okay, good afternoon, everyone. My name is Matt Johnson. I'm a solutions architect with the AWS Public Sector team, and hopefully you're here today to learn a bit more about EC2 Systems Manager. Just as a quick show of hands, how many people here have heard of or used EC2 Systems Manager before? Okay, pretty good. So what we're going to do today, what you can expect from the session, we're going to give a brief overview of some of the capabilities that the service offers. We're going to dive a little bit deeper into talking about how we set up EC2 Systems Manager. And that's both for EC2-based instances and on-premises as well. Then we're going to do a few walkthroughs. They will be sort of slideware rather than live demos. But then at the end, after we've done some advanced use cases, we might see if we can risk a live demo. So as you would have heard in the keynote this morning, cloud is the new normal. We've been saying that for a while now. And there are obviously a number of reasons why you want to move to the cloud. Things like increased speed and agility, the ability to scale up and down on demand, the ability to move from on-premises into an OpEx cloud-based model, and so on. But what we find is there are a number of customer challenges faced, both in the public sector and the private sector, when we move from running infrastructure on-premises into a cloud-like environment. Traditional IT tool sets typically aren't built either for the cloud workflow in terms of standing things up and down on demand, but also in terms of the scale that you can deliver IT on the cloud. Maintaining visibility of what's happening across the cloud is quite challenging if you're using traditional enterprise-type tools. There's an overhead in terms of deploying multiple products to help manage and maintain your infrastructure. And then obviously there's licensing costs and complexity as well. So really, the takeaway from that we found is that managing cloud and hybrid environments, because obviously it's a journey and many people are going to be looking to manage on-prem as well as cloud-based stuff, is both complex and costly, especially when you're using traditional infrastructure. So back at reInvent last year, we introduced an expanded product in the terms of Amazon EC2 Systems Manager. And this has a set of capabilities that enable automated configuration. It supports ongoing management of systems at scale. It's designed to work across all of your Windows and Linux instances. And also, and this is sort of key from our point of view, it runs both in EC2 and on-premises environments, and no additional charge to use. So you'll be charged for any EC2 instances that you spin up as a result of this or work that you use, but the actual service itself is free of charge. And it has a broad set of capabilities as well. So run command, this is probably the first service that was launched, and this was a couple of years ago. We'll drill into that. State manager, you can think of this as desired state configuration. Inventory, the ability to capture, process, analyze, and store inventory information on OS instances, on the OS. Maintenance windows, the ability to schedule tasks at particular time periods. Patch management, how you manage your Windows environment for patching. Quite relevant in these times. Automation, how you can help build new AMI templates to be able to launch, and parameter store. And this is one of the key ones, I think, how you manage and store parameters securely in the cloud and then make use of them without having to store them, hard code them into applications. So if we look briefly, run command. This allows you to remotely and securely manage servers or virtual machines at scale, running in your data center or in AWS. It allows you to automate common administrative tasks, anything you can do in PowerShell, anything you can do in Bash or other sort of scripting language is possible. It allows you to deploy and run commands across fleets of instances at the same time. It supports both AWS and on-premises, and we'll talk a bit more about how that works later. Really important, it has granular permissions available through AWS Identity and Access Management. So this means you can give your IAM users specific permissions to run certain type of commands and not others. And any commands that they do run, both the execution and the outputs are tracked using logging in S3 and AWS CloudTrail. So you have a very clear audit of what's happened on your environment. Something that's actually a lot more difficult to get if you're using things like SSH Bastion hosts. State Manager allows you to define and maintain configuration for your infrastructure, whether it's operating systems or applications, whether it's running in your data center or on AWS. And it allows you to do things that control configuration details, so you can ensure that antivirus is up to date. You can configure IP tables or firewall rules on your instance. You can define your own schedules for things like deployment reviews. You can compare what is deployed with what should be deployed and spot any state drift. And you can query to see the status of deployments. So think of this as your management for desired state configuration. Then we have inventory. And this, I think, is quite big for a number of customers. So this provides visibility into the software catalog and configuration that is on your instances. So we are able to gather details on a wide variety of attributes. So not just the OS, but we can also look at what applications are installed. We can look at things like which AWS components are installed. We can also look at things like the network configuration. So you can use it to pull out things like IP addresses and so on. Really importantly, this inventory information is then stored in AWS Config, so you can start using AWS Config and things like config rules to start tracking what's happening on your infrastructure, not just at the AWS API level, but also at the OS and application level. So a one-stop shop for seeing exactly what's happening on your infrastructure. We can also assess compliance using config rules, and if we have time, the demo will show a little bit of that later. Maintenance windows. So as everyone knows, particularly when you're looking at traditional type deployments, trying to figure out when to deploy certain sets of patches and so on can be problematic. Maintenance windows allow you to define recurring periods of time during which you will accept disruptive operations. You can prioritize tasks that are delivered within that time period. And you can create different maintenance windows for different groups of servers. So you may have a maintenance window for your development fleet, one for your production fleet, a separate one for your test instances. And again, as with all the stuff we're talking about now, it's available and works across both EC2 and on-premises. Patch Manager. So this is an automated tool that helps you simplify the Windows operating system patching process. So you're able to select the patches you want to deploy. You're able to define what we call patch baselines. So these are collections of patches that your infrastructure should conform to. You can define auto-approval rules so that critical patches are deployed on your development fleet within a day, whereas updates may be deferred for 7 days. You can choose to whitelist or blacklist particular patch types. So there may be a particular patch that you need not to deploy because it breaks your application, so you can blacklist those. And you can schedule the automatic rollout of these. So this integrates with maintenance windows, so you can start doing your patching during one of your scheduled maintenance windows. Automation. This provides a way of taking an AMI and then applying a set of automated controls to build a new AMI with a revised patch level or with additional applications configured on it and so on. So this allows you to effectively help automate and manage your AMI baking process. This is really important if you're looking at automating deployments of things like auto-scaling groups, how you manage that at scale. We have set predefined workflows, or you can build your own. And then lastly, we have parameter store. So this is a key service, I think, for us. It's a centralized store which allows you to manage your configuration data. So not just necessarily secrets, but any configuration data you might want to access at scale. It includes plain text and secrets, and it's encrypted using KMS. So this means you can store critical information within parameter store and not need to have it stored in the clear on your instances. It integrates with things like AWS IAM, KMS, and CloudTrail, so you can control who has access to which parameters. It enables you to effectively reuse the same configuration, but then pull in specific parameters from the parameter store for specific deployments. So you might have a development password and a production password for your databases. If you deploy in development, you access the parameter store for the development key. If you deploy in production, you access the parameter store for your production key. You can also reference that from other services such as EC2 Run Command and State Manager. And you can also pull it using the CLI, so it can integrate with other services like Lambda as well. And if you follow our management tools blog post, and I'll talk a bit more about that in a minute, you will be able to see already we've done some use cases around ECS as well. So that's an overview of the 7 services that come as part of EC2 Run Command, Systems Manager. Now we'll talk a little bit about the prerequisites you need in order to deploy this. So firstly, you need to control IAM access to EC2 Systems Manager. So this allows you to users to do things like create documents, to create automations, to execute run commands, and so on. For the purposes of the demo, I'll be an admin user, so I'll be able to do everything. Strongly suggest that in production environments, you think about managing your IAM permissions so that users can't do an RM minus RF. That's a bad day. For managed EC2 instances, you will need an EC2 instance rule associated that allows that instance to talk to the EC2 Systems Manager endpoint. For on-premises, we create an IAM service rule, and we also create what we call an activation code that allows that on-premises instance to manage, authenticate and register with the Systems Manager service in AWS. And lastly, we have to have an SSM agent installed on the machine that needs outbound HTTP access into our EC2 Systems Manager endpoint. So that's the only requirement. There's no inbound access needed for this at all, so you don't need to open up firewalls inbound on your infrastructure. It also works through proxies as well, so if you have a controlled environment in which you want to restrict outbound access, as long as you whitelist the appropriate endpoints, you can control access outbound as well. So just a quick walkthrough in terms of how we create an EC2 rule for SSM. We go to the IAM console. We select the service rule type. You'll notice that at the bottom we've got an EC2 rule for Simple Systems Manager, so there's already an AWS managed rule type for that. We can attach a managed policy. So again, this is an AWS managed policy. You don't need to worry about defining the particular policy sets yourself. We can attach that to the rule. And then for on-premises, there is an additional step. So we need to establish a trust relationship, not just with EC2 that we would have for the EC2 instances, but we also need to allow SSM to assume the role in an on-prem environment. So we do that by editing the trust relationship. Again, this is on the documentation. There's links there if you need it. But what we do is we add in SSM as a trusted service that can access that role. Then lastly, for on-premises environments, so you don't need to do this for EC2 instances. Once you've created the role and attached it to an instance, provided it can talk outbound and you have the agent installed, it will register automatically. But for on-premises, we need to create what we call an activation. An activation allows you to create up to 1,000 instances at any one time, and that will basically give you an activation code and a unique ID. You supply those roles, those credentials into your agent when you install it, and then that will be able to register your on-premises instance into your AWS account. Once you've done that, you'll get a screen like this, an activation code and an activation ID. Make a note of those because those will only be displayed once. They're your credentials to look after, and then you can feed that into your on-premises environment, whether you use something like Puppet or Chef to deploy your applications, or whether you do it manually. You will use those codes to register the instance. The final thing we need to do is install the SSM agent. So the SSM agent processes requests, configures instances, it captures things like the inventory information and so on. It supports a wide range of Linux operating systems, everything from Amazon Linux 2014.03 and onwards, Ubuntu 12.04 and onwards, Red Hat 6.5 and onwards, CentOS 6.3 and onwards, and only a couple of weeks ago we launched support for SUSE Linux as well. From a Windows perspective, we support everything from Windows Server 2003 onwards, including the R2 versions. And it's worth noting that for Windows instances launched after the end of November last year, the SSM agent will be part of the EC2 tool package that is installed. So SSM agent will already be available on your Windows instances that have been launched from December. However, for Linux instances, even if they're Amazon Linux, you will still need to install the code. I should have mentioned as well, the source code is available on GitHub. It's written in Go. We accept pull requests, so if you're interested in contributing to this or helping to port to additional operating systems and so on, please do that. Feedback through GitHub, the normal channels, and then we'll have a look at that. In terms of how we install the agent itself, so it's a very simple. We have a command line. I appreciate for the people at the back, this may be a little bit awkward, but effectively we download an RPM package from a CloudFront distribution, or an S3 bucket, I should say. We then simply do a sudo yum install for Linux or apt-get install for Ubuntu and so on. For on-premises, we pretty much do exactly the same. The only difference is when we install it, we need to feed in the activation code and the ID that we identified previously. For EC2, it's even simpler because we can put this as part of user data. So we can actually just choose to Sorry, beg your pardon, we're on the Windows section. My apologies. So for Windows, again, an EC2 instance, very simple to download and install. If you're running an older EC2 Windows instance, if you're running a newer instance, it will be there already. For on-premises, pretty much the same thing. You need to make a connection to the endpoint, download it, install it with the activation code. If you want to bootstrap this installation with EC2 user data, then you can. It's, again, pretty straightforward. You add it to the user data of your EC2 startup, and that will effectively do the same thing on first boot. In this example, we're just installing the agent. What you'll notice as well, we had to make sure that the IAM role is associated. Until recently, it wasn't possible to attach an IAM role to a running instance, so that would have meant restarting. Now we support the ability to attach IAM instances. So you can now quite easily add EC2 Systems Manager and the SSM agent to your existing fleet, even without having to restart. So that's how you boot it normally. If you're interested in CloudFormation, there's also a very simple way to do it using CloudFormation, using CloudFormation init. So here we simply set some metadata within the definition that pulls down the RPM from the source. We then run a command to effectively stop and restart the agent, and the agent is then up and running. And in the user data, we simply call CFN init to actually execute the metadata. So again, there's documentation available on that, or if you've got any questions around that, speak to me after the session. Once it's installed, we can check to make sure it's running. Now, one of the key things and one of the benefits of using EC2 Systems Manager, and we'll talk about that in a minute, is you can actually remove the need for having any inbound access to your instances at all. So you don't need an SSH Bastion host anymore. We can get away without that. But in order to check it, we need to be able to just have a look to make sure it's running. So we can do that through the console. If you go into the instance settings and then look at Get System Log, you will see a page like this. This is effectively your first run boot script that you will find. Just look for something that says Amazon SSM agent installed. That version might be slightly different. And you're up and running. The final check you can make is if you look in the EC2 Systems Manager console, you can look under the Managed Instances tab, and you can check to see that we have a ping status. So here you can see we've got some instances that are reporting back that they're online. We can see whether they're Windows or Linux, and we can see the version of the agent that's been installed. So that's the prerequisites. We now have SSM agents set up and ready to go. So let's start with a simple walkthrough for run command. So for run command, what we do, we go to the console. So all of this is available in the EC2 section of the AWS Web Console. It's near the bottom, so you need to scroll down a little bit. It's under Systems Manager Shared Resources, and we have a tab called Managed Instances. And this will show all the instances, whether they're managed instances or on-premise instances that are managed, and that will display, and we can then choose to run a command from there. So there's a run command box, and obviously all of these things can also be done from the command line, from the API. I'm showing the console because it's easier, but in practice, in production scale, you will probably be doing this through the console, through the CLI or automation tools. So what we then do is once we're in a run command, we get the choice to run a series of documents. And I'll talk about those a bit more in a minute, but you can think of those as the things that run command will do. So you can filter that by ones that are owned by you or being produced by Amazon. It's also possible to share command documents as well, so you can write them and share them across accounts if you run a multi-account infrastructure. Or indeed, you can use third-party ones and publish them if you've got a particular run command command document you think would be very useful. So you select the command document. You'll notice that some documents are specific to a particular platform. So in this case, run shell script is only applicable to Linux. If it was run PowerShell script, that would only be applicable to Windows. In some cases, they're applicable to both. Once we've chosen it, we get to choose whether we're going to run it, or what instances we're going to run it against. From our point of view, we can have two choices. We can run it against a particular group of instances by selecting a tag and a value, a tag key and a tag value, or we can manually select the instances as well. So in this case, I've just selected 4 instances to run it against, but typically, again, tagging you would choose, so you would tend to run it against your development tag, fleet that's tagged as development or so on. We have a few more things, so the actual command itself. So in this case, very simple df-k to find out how much disk space I've got. The working directory, so if your application needs to run in a different directory from the default. The execution timeout, so how long that particular command will have to execute before it reports back as timed out and failed. So in most cases, you can probably lower it from the default setting, but you may want to set it, if it's going to do a lot of processing, you might want to set it to 5 minutes, 10 minutes, something like that. And lastly, you can add a comment. This is optional, but it's useful because you can then identify that in the list of run commands in the interface later on. It's also possible to write the output of this not just into the console, which is truncated at 2,500 characters, but also into an S3 bucket. So that will give you the ability to post-process all that data afterwards. And you can choose a particular bucket and a prefix to put it into. And you can also get notifications. So you can set it up to send to a particular SNS topic. And you can choose whether you want to be notified for things like on failure or on success or on all states, and also whether you want to be notified for the overall status of the command execution or for each individual invocation. So bear in mind, if you set notification for all states for invocations and you're doing it across 1,000 fleets, you'll get 1,000 notifications. So please think carefully before what you set that for. So once you execute that command, it will come back. It will say the command has been successfully executed. You will get a command ID. If you click on that, you will then go into a filtered view of the run command interface that will show the command ID, the instance ID, and the status of the execution. So in this case, it's run on 4 different things. It shows the document that was run, the time it was run, and the status. So in this case, this was a success. If I click on that success and drill into it a bit more, there's a view output, and there in the view output, I can see effectively the state of the file system on that instance. But that's done over 4 instances. It could have done over 400 instances. They could have been on-prem, in EC2, and so on. In terms of a concurrency model, you can specify the velocity at which you want to execute those commands. So you can choose to execute simultaneously on 2 instances at once or 10 instances at once, up to about 50 instances at once. Or you can say a percentage of the instances in the fleet, again, up to a maximum. And the way the queuing system works is it will start by sending a command once, then it will double, then it will double again, it will keep doubling until it reaches the maximum size of concurrent requests that you want to make. So if you're dealing with a fleet of 1,000 instances, you set a default to 20, it will send 1, 2, 4, 8, 16, then 20 at once. It will keep doing it in batches of 20 until it's done the entire fleet. As part of that, you can also choose how you're going to handle errors. So you can specify how many error responses. So cancel if I see 5 errors come back from the command, or cancel if I see 5% of the fleet is returned an error. And again, those are thresholds that you can set. What will happen is once that threshold is breached, the command will stop executing new commands, but existing ones will obviously still continue to execute and either pass or fail. And then you'll see those results in the console. So that's a very quick walkthrough. Hundreds of use cases for EC2 run command. One that we've identified and is particularly relevant when you're looking at security by design is reducing the surface area. To do that, you can actually look at using EC2 run command to replace your Bastion hosts. So Bastion hosts are a traditional design where they act as an SSH jump box. You log into the Bastion host, and from there you access your private infrastructure. Actually, we can remove that now because we can now do things like looking at instances, restarting services using EC2 run command. It gives you a couple of benefits. One, it reduces your attack surface, and also it gives you greater visibility into what's been done on that instance, because it's quite challenging to start following what operators are doing on SSH instances, how to capture those logs, how to feed them back into a centralized system. Because run command integrates with IAM, it means that we can capture all of that using CloudTrail, and we can start seeing what's happened, when, who by, and so on. So it's great from an audit perspective. Okay, that was run command. Next, we're going to look at State Manager. So State Manager is effectively a way of saying we want to do a run command or apply a particular set of changes at a particular period of time on a recurring schedule. And to do that, we create what we call an association. So an association effectively determines the actions to be applied, and that's done using a command or a policy document. So in the same as we use the run command, run batch scripts, we can use a command document there. We determine the managed instances to be targeted. Again, we get to say whether it's a tag, key, or value, or by selecting a group of instances manually. And we determine the schedule. So it can be every 30 minutes, every X number of hours, or every week on a particular day at a particular time. You can also specify a cron expression as well, so you can go for much more sort of granular or complex time patterns if you wish. To do it, again, if we go to the EC2 window, under the Systems Manager services, we have State Manager. Within State Manager, we can then create what we call an association. For the association, when we walk through it, we choose a document. It's possible to choose a particular version of a document. So if you create multiple versions of your document, you can then choose for every association which version you're going to run. So it's great for sort of A/B testing of your run command and state manager infrastructure. You can also then specify which targets. So this, again, is select by tag. So here I've chosen to target all instances that have got an AWS system tag called CloudFormation stack name SSM AWS. And I'm going to run it every Monday at 2 a.m. in the morning. If the document you've chosen supports parameters, you can define your parameters in there. You can also embed things like parameter store values in there. So if you need to better get passwords, you can pull that from parameter store on demand. You can choose to write the output to S3 if you wish. So again, if you want to capture all that data for future processing, then that's fine. And again, once you've associated that, you will see an association ID. And when you click on that association ID, you'll see a list of instances and you'll see the state. And that will be sort of pending, in progress, success, failed, or so on. And that means that at that time, that particular command document has been executed against that particular instance and will be re-executed every hour, every day, whatever the cron expression was. So again, lots of different use cases for this. One that's proved very popular and has got a lot of interest is one we released recently, which is integration with Ansible. So a configuration management tool. So this allows you to execute configuration management directives using Ansible and EC2 State Manager. It makes use of a document we've published called AWS Run Ansible Playbook, and as it might suggest, you choose the Ansible playbook you wish, you point it at its location, and it will then go and apply that playbook. Nice thing is, all the executions of that and all the outputs of that will be tracked in CloudTrail and on S3, so you can see what's been happening to your infrastructure at any particular time. Next walkthrough we're going to go through is inventory. So for inventory, this is where you use State Manager, so what we've just talked about, to schedule a regular collection of inventory from your instance. So you could do that once a week, once a day, down to a minimum of every 30 minutes. And there's a policy document for that. It's called Gather Software Inventory. It runs on both Linux and Windows instances. And effectively, it uses the SSM agent to retrieve the items that are configured. You can determine the type of inventory that will be collected. So you can look at installed applications. You can look at things like software components. So if we've got the CloudWatch Logs agent or the inspector agent, etc. You can ask it to pull the network configuration. So at any particular time, you can see if its IP address has changed. You can pull custom inventory information. So you can actually choose to start writing things like on an on-premises environment, you might choose to write this particular VM is sat on this physical server, which is in this particular rack, in this particular building, and so on. So you can push that information in. And lastly, for Windows instances, you can look at the status of Windows Update as well. We view that through the console. So again, we look at the Managed Instances tab. From there, we have a tab called Inventory. And then from there, we're able to see, in this case, this instance has got the Amazon SSM agent installed on it. It's got PV power virtualization drivers, the CFM Bootstrap agent, and so on. It's also possible to do that using the command line. So if you want to pull that out and export that data, you can do that using the CLI. And this is probably, for me, really, really important, integrates with AWS Config as well. So not only will Config now for that instance show you what's changed from an Amazon API perspective in terms of things like I've added a block volume or I've changed the security group setting or so on, it will now say on the 23rd of February, we made some changes, and that was we installed some software, or we removed some software, or we changed the patch level, or we changed the network configuration, or we added CloudWatch Logs agent, for example. And again, this is part of, this is information that's recorded within AWS Config, so whatever you can do with AWS Config, such as config rules and so on, will also work with this data. So you can start to begin to build really functional, automated, deep workflows around things like, have I installed a particular version of the application? Do I know if that version is vulnerable? If so, I want to report that as a config rule. That config rule will report those as non-compliant. It's then possible to automatically remediate that by sending a run command that does a yum update. So as you can see, you can begin to build really complex, powerful workflows that will build out and manage your infrastructure automatically. Also integrates with things like Amazon QuickSight, so you can start doing reporting against that. And because you can, it's accessed over the API, you can start pulling data back into third-party tools as well. The last walkthrough we're going to cover now is for documents. So documents are what happens within this infrastructure. So documents define the actions that are performed on the managed instances. And there are three types of documents that we currently support. There are command documents, which are used to define and execute either a single command or a group of commands. There are policy documents, which allow you to enforce a policy on targets. So, for example, a policy that requires you to gather instance inventory every half hour. And lastly, automation documents, which work with the automation service to do things like define the steps needed to build out a new AMI. And those might include executing other command documents, such as run a shell script that runs updates or pulls down or installs software and so on. So the automation documents can also reference other documents. In terms of the format of the documents, they're formatted in JSON. They support editing and versioning, certainly since the new version was released back here at reInvent. There's a sequencing of steps within there. And you can use the AWS managed ones, you can use your own ones, or you can also find ones that have been shared from other accounts. In terms of the document itself, its structure, you will have a version, so the schema version. So we're on schema version 2. The previous run command was schema version 1.2. So you may see some old legacy documents if you used if you used run command when it was launched back in 2015, 2016. You may see some command documents that are structured with that, but we highly recommend move to the newest version. This allows you to do a few more things like structure steps. So you can have multiple steps within the command. They can be dependencies, so step 2 will only execute if step 1 succeeds, and so on. And you can also parameterize the inputs. You can say, I want it to work basically on a production environment or a dev environment or an IP address that's provided, and so on. And this is really what a command document looks like. Apologies at the back if you can't see that very well. But the key here is we've created a very simple run that does a check update, counts the number of lines, gets rid of the header line, and then reports back saying there are X packages that need updating. So very, very simply, it's a tool that allows us to check Linux instances to see how many packages are available for updating. Where it gets really interesting is how you start integrating that with other services. So we integrate with CloudWatch Events. We integrate both as a source and a target. So for people who aren't familiar with CloudWatch Events, these look for specific activity within an AWS account and then allow you to trigger responses based on that activity. So in this case, we act for event type, so you can trigger something when a run command runs or when an association is applied. You can look for specific statuses, so I'm only interested in triggering this CloudWatch rule or CloudWatch event rule when a command invocation fails. And I'm only interested when it fails on production instances. So you can start producing a really granular set of sources. And then from a target perspective, you can also target run commands. So you can say, as a result, I might have a CloudWatch event that says, checks to see if SSHD is installed on my instance. If it isn't, if it is, then perhaps I might run a document that removes it because I don't want SSHD available on my infrastructure anymore. Those targets can pass information such as parameters and IAM rules and so on. So it's able to build a very tightly integrated, tightly coupled service. As an example, so a very quick walkthrough, here is a very simple Lambda function written in Python that takes the output of a run command, parses it, and then effectively takes each invocation of that run command and stores that as a separate log in CloudWatch Events. In CloudWatch Logs. So this means that I'm able to set up something, and as an example, it's not particularly thrilling, but what it does mean is instead of logging it in CloudWatch Logs, I might actually choose to execute a run command that patches it, or sends a report to security saying, this instance has got something installed that it shouldn't, or so on. And so what happens is, going back to the CloudWatch events, we create a rule. In this case, we're looking for a run command, any status change notification. We then target the Lambda function that's just been written as the source. So this will mean that any time a command is invoked, it will execute that Lambda function. That Lambda function would run the code I just mentioned, and you end up with the output in CloudWatch Logs a bit like this. So it's just logging out, in this case, the update. For every instance, it's telling me how many packages need updating. So again, we've got some examples of this on the Management Tools blog. This one's quite an interesting one, and it is only scratching the surface of what's possible. But this is things like Remediate Amazon Inspector findings. So Amazon Inspector is an agent you can install on EC2 instances that will allow you to check for things like CV vulnerabilities, for suspicious network activity, and so on and so forth. And what we can do is that can trigger a Lambda function, which can then call EC2 Systems Manager to update the instance and remediate the issue. And that's got a broad application to multiple use cases in terms of patching, security updates, permissions, versioning, and so on. It's worth mentioning here that we've only scratched the surface. So that's a walkthrough of 4 services at the moment. We've got 3 more that we've talked about. So for maintenance windows, as I mentioned, automatically perform tasks and define windows of time. And we can prioritize tasks within that maintenance window as well. So it allows us to say, we really want to make sure we patch this. If we've got time afterwards, we might do some log file maintenance and so on, but it ensures that the key priorities are carried out. And those tasks are executed with specific control permissions granted by IAM. So you can say that a particular task runs with a particular set of permissions. So you can be very granular about what it can do within AWS. From a patch manager perspective, this is currently Windows only. We're actively working on support for Linux. But at the moment, what we can do is we can manage patch baselines. So this allows you to define the patch baselines both by products. You can have a patch baseline for Windows Server 2012 R2 and a separate one for 2016. Or by categories, you can have a baseline that says we want to address all critical updates, or by severity, so anything that's important or an update or so on. And then you can start defining approval and distribution schedules for those specific baselines. What you then do is you associate that baseline through a tag in EC2 tool patch group, so you could then define which set of baselines apply to which particular group of instances. And then patch compliance allows you to scan the existing fleet, see which patches need to be applied, see which ones are available, and then, if necessary, apply them either immediately or during a maintenance window or as part of an association. So again, multiple ways of doing that, depending on whether it's a dev environment you want to patch immediately or production and you need to wait for a scheduled maintenance window. Automation. So this becomes more and more useful as you sort of increase your journey into AWS and you start doing things like immutable deployments, you start building AMIs on a regular basis. This allows you to do things like maintain and update your AMIs. We integrate with CloudWatch, so it might be that if you what you want to do is, if you've created a new AMI, you may then choose to update a launch configuration of an auto-scaling group so that you can then relaunch all your instances with the next set of updated AMIs. It also means that you can take an AMI and bake new versions of your application into that application at any particular time. So it's a great way of automating your change management process from an AMI template perspective. And then lastly, parameter store. So from our point of view, parameters are security items. They're customer data. We want to keep them as secure as possible. So parameter store allows you to take parameters and store them securely encrypted with KMS. Worth pointing out, in the console, it uses a default key. If you create the parameters from the command line, you can specify your own custom KMS keys as well. And then what that means is you can grant IAM permissions to be able to access those parameters, whether they're plain text or secrets, in your instance or in your run command documents and so on. So the use cases, again, multiple use cases. One of the earliest use cases were for things like doing an automated domain join. If you need to have a username and password that allows you to domain join a Windows server, then you can do that by creating a secure string parameter with the domain join password and then control access to that so that it's available in the run command document, but it's never actually installed or visible in any logs anywhere on the instances. Recently released, as in, I believe, last week, we now support parameter hierarchies. So before, you just defined the parameter as a particular name and they had to be unique. Now we support a path-based solution. So we can now say production/Windows/database/username. And now what we can do is, within IAM, you can grant permissions at a resource level that say only this set of IAM users can access anything under production. So people who are in the developers team can access production secrets. So it's a great way of splitting parameter security across customers. So in summary, hybrid. Yeah, that's key to point out. This works on premises and in AWS. It's cross-platform, supports multiple flavors of Linux, multiple versions of Windows. It's highly scalable. It's designed to run at cloud scale, thousands and tens of thousands of servers. It's highly secure. It's effectively, there's no inbound access to the instances, very granular controls around IAM permissions. Very easy to write in terms of automation, and hopefully a reasonably well-reduced total cost of ownership. So, that's me. I've got about 10 minutes left. Quick show of hands, you've got a choice. You can either leave 10 minutes early, or I can give a very quick demo and see if I can break things on the internet. Demo or leave? Demo. Okay. All right. So this is my EC2 console. If you look, I've got 60 running instances at the moment. If I just look in this, I've got various ones. So I've put 3 tags on. I've put the tag environment, whether that's development or whether it's production, OS, whether it's Linux or Windows, and patch group. So patch group only applies to Windows. But if I look at the Windows, I've got things like dev batch 1, dev batch 2, and so on. So what we'll do, we'll just show a very simple run command demo to start with. So I'm going to go to run command. I'm going to choose to run a command. Let's go for run a shell script. I want to do it against the tag. That tag name is going to be OS. The value is going to be Linux. I'm going to choose to execute it on 5 targets concurrently. I want to stop after 2 errors. And the command will be df-k, because I don't want to break anything. Live demo. And then we will run that. So that's now executed. If I look at the command ID and filter that, I can now see. So it's targeting more than 30. Some are in progress, some have succeeded. If I hit refresh on there, I can now see that the majority of them have succeeded. If I click on one of those and I go to the output, and I go into view output, I can now see I've got the live df-k output. So that was a very simple example. Let's go for something a little bit more complex, since that one worked. So if I go back to AWS Config, what I've got here is I've got a rule that says that a rule that checks the managed instance inventory that I've collected through the state association that I've done for gathering inventory on those instances. I've got an application that I've blacklisted called RSSH, so remote shell. And I don't want that. So if I look here, I can see that the rule will show me it's evaluated a number of instances. And here are the non-compliant ones. There are some compliant ones. So actually what I want to do is probably go away and try and fix that. So I will go into EC2. I will go into run command. I'm going to run a command. Again, it's going to be a run shell script. I'm going to specify a tag, OS, Linux, execute on 5. And this time I'm going to do a yum -y remove RSSH. And then live demo 2. Run that one. So because this is doing something other than a very simple command, it will take a little bit longer. But again, I can look to see which ones are in progress, which ones have succeeded. Just while it's doing that, if I go back to config, and this is where it gets sort of really interesting. If I look at these rules, and I can see there's some that are non-compliant. If I click on the config timeline for this, I now go into the nice graphical view that shows me the state of the instances at that particular time. So I spun up the instance here. I then made a change here, and I made a change here. If I look at this change, you can see here that it's tracked the fact that I actually installed RSSH. So my initial state was from nothing, state 2, having that application installed. And I can also get a lot more detailed information in terms of from a programmatic perspective, what those details look like. So this is available in sort of JSON format, so you can then start consuming this in things like ServiceNow or other type of CMDB tools. So you can then start automatically tracking what's happening. So what will happen just in the background is, if we look at this run command, so they've succeeded. So what we want to do now is that hopefully no longer has the RSSH instance on there. Now I've got an association, a state manager association, that says I'm going to gather inventory on production and development environments every half hour. But what I'm going to do is, just to trigger that, I'm going to apply that association now. So it's going to go away and actually re-execute that now rather than every 30 minutes, because I don't want to keep you from the next session. And what we'll do is if I tap into the Instances tab here, it will then tell me what's happening here and the last execution time. So it's pending at the moment. In fact, the last execution time actually executed only 3 minutes ago anyway, so it's just reapplying this. We'll just wait for some of that to come through. And then after a couple of minutes, what will happen is that information will feed back into AWS Config. And if I look at some of those instances now, I will see there's another item in AWS Config that will show that it changed from having that to not having that. So I've now got tracking of what happened and what hasn't. And then again, with AWS Config, if we look at the rules, so this reevaluates every few minutes. So at the moment it still says 20, but after a little while that will change, and hopefully that will go down to 10 because my 10 production instances are no longer running our SSH. So that's just a very sort of quick, straightforward workflow on how to use that. Lastly, because I've got 4 minutes left, for people who are interested, this is how the Windows patch works. So if I look at patch compliance, I can report by instances or patch groups. So here I'm going to report on dev patch 1. So this is telling me that based on the most recent view of the data, 5 instances are up to date, none are missing updates, and none are in error states. If I look at production batch 1, that's the same. But if I look at production batch 2, actually you'll find that 5 instances are missing updates because I haven't patched those yet. And if I drill into that instance, I can then start looking at the patches that have been applied to it. I can go even granular, so I can start filtering. I can say patch status to be missing. So it's actually telling me there's 2 patches missing there. Okay, so that's great. So this is batch 2. So what I would do, I will actually take that ID, and again, this is something that you could do automatically, but I could choose to run a command. I'm going to install a specific Windows update. I'm going to specify it against a tag, and it's against a patch group. And it's a prod batch 2. I'm going to execute it on all 5, and I'm going to provide the parameter, which is that document, live demo 3, and run that. So hopefully what that will do now is that will go away, and now that's applying that knowledge base patch to 5 instances simultaneously based on the fact we've identified that that patch was missing. Now, if we'd set up maintenance windows, and unfortunately there's not time to demo that here, that maintenance window would have done that for us. So at 2 a.m. on a Sunday, it would have identified that those patches were missing, not in compliance with the patch baseline, and therefore would have gone away and installed that patch. These patches take a while because they're going and pulling the data and then installing it, and in some cases they may need to reboot it. So we will sort of leave that running, and we'll just quickly go back to the console. Yeah, no, so it's not quite updated yet in terms of the effort. But again, if I click into one of these, once config updates with the data, I will see that in the config timeline, I will have another item in there saying that's now been remediated. Okay, and that leaves me with 2 minutes to go. So I think at that, I'll probably give you a couple of minutes to get to the next session. And thank you very much for your time.